what is the name of the seminar? So it's a regular topological
seminar. Yes.
Regular seminar. So I'm very pleased to introduce today's speaker of the seminar, Tomoo Yokoyama from Hokkaido. Hokkaido is a northern part of Japan. A lot of snow. Well, anyway, the title of his talk is World Representation of Streamline Topology for Structurally Stable Vortex Flows in Multiply Connected Domains. Hopefully, Word is not Microsoft Word.
Or Japanese words?
Well, no. It's an alphabetic word I understand. So, Doctor.
Okay. So, thank you to the organizers. I'm honored to the opportunity to speak here. So today I will be talking about the word representation of the streamline. So, so this is content. So first, so I'm talking about the background, and second, I'm talking about the schematic picture. So what is schematic picture? These are usual flow line, but so these are schematic picture is a little bit simplified. So like these pictures, and because why we consider the schematic picture is a preparation to the define the word representations, and finally I show the all list of the generic streamline in so compact manifold, so with genus 1 and 1 or 2. And so why we consider the word representation? Because so we'd like to say so which flow is so similar or so which flow is so different, very far from each other. So and so moreover, so for example, we consider like this lever. So when some item disappears, so how to change the flow? So if we consider the word representation, so they say what happens next, and so they told me the possibility. So therefore we like to consider the word representation, and so especially we consider so in the multiply connected domains because so in nature so many flows so can be found so in the domain with so boundary. So yes. And so precisely so we deal with a vortex flow. So it's a kind of so potential flow with a point vortex in presence of the uniform flow. And so potential flow, so it's incompressive, so in viscous, in rotational flows. It's a so integral curve of the velocity fields. So velocity field is a Hamiltonian vector field for stream function. Maybe everybody knows this fact, but I recall. So what is the Hamiltonian? So Hamiltonian is so this is a definition, but now we deal with a 2D case. So in this case, so this can be written like this, and the stream function is of course so imaginary part of the complex potentials. And there's some previous works. So 98, so RF and Brown, so topologically so classifies the vortex flow in the unbounded plane with the so uniformly flow and so boundary. Also, Kidambi and Newton so deal with the so spherical case without a boundary. And so Alexander Bond so draw like this picture. This is a saddle, and so they deal with the all flow. So, for example, so these are homoclinic orbit. They also deal with heteroclinic orbit. So, but we focus on the structurally stable flow. Structurally stable flow is a very generic flow. So actually, so they form an open dense set, and they are invariant for small perturbations. And so our work is so extension of these works, and to the with boundary, and we consider some structure. So actually, so new point is these 3 points. So first is we deal with so uniformly flow. So uniformly flow is roughly Hamiltonian vector fields with one sourcing point. After I gave a precise definition, and second, so we deal with the boundary. So previous work, so they don't deal with the boundary, but our work deal with the boundary, and of course we can deal with usual Hamiltonian vector fields, so without seeing consorts, but we can consider both case. And so third one is structurally stable. So we deal with a structurally stable flow, and structurally stable flow is a very generic flow, and so invariant. And so recall some mathematical facts. Let S be the compact oriented surface. So for example, multi-connected domain, and so denoted by the H of S is the set of the Hamiltonian vector fields on S. So recall, the vector field is regular if each singular point is non-degenerate. This means so the derivative at the point is non-singular, but in 2D case, so this means so a 2D case, and so now we deal with the incompressible flow. Therefore, so we don't consider the another singularity. So just in this case, we have just two singularities, so center or saddle point. So and so 2005, so Ma and Wang showed this fact. So suppose V is a Hamiltonian vector field on the compact oriented surface. V is structurally stable in H of S if and only if V is a regular, and so boundary saddle connection and the saddle connection is self-connected. So now I explain self-connected. Self-connected means so first we consider saddle, and so self-connected means like this. They go back themselves. So saddle connection is self-connected means so figure is 8. So figure 8 shape is a figure 8, and the boundary saddle connection is so like this. Like this. So this is self-connected. So this case is not self-connected.
I think you've got the arrow wrong in the lower diagram, haven't you?
Lower diagram.
Yes. Does the arrow indicate the direction of the stream?
Oh, sorry. Yeah. Oh, sorry. Yeah, you are right. So I mistake. Yes. Yes. Okay. This works. Thank you very much. Yes. So yes, this is a self-saddle connection, and this theorem says if Hamiltonian vector field is structurally stable, so every saddle connection, so the shape is like this shape, and moreover, they shows that structurally stable Hamiltonian vector field is open dense. So if we this says if we perturbate a little bit, so we can find the structurally stable, and this also says in nature almost every Hamiltonian vector field we observe is structurally stable. So this record structurally stable means any vector field which is C1 near of V in H of S is topologically equivalent. So topologically equivalent means streamline is the same. So same means that there is a homeomorphism to map each orbit to orbit. And so therefore structurally stable means it's invariant small perturbation. It means that they don't change the streamline. And also, any they show that any structurally stable Hamiltonian vector field on a compact orientable manifold orientable surface is determined by the union of the saddle connection and the boundary saddle connection. It's called a saddle connection diagrams up to topological equivalence. So this means if we consider flow, it's enough to watch just a saddle connection, boundary saddle connection. So because Hamiltonian vector field on surface, if we consider the complement of the saddle connection diagrams, its components just center disk or annuli, filled up the periodic orbit. Just a complement consists of like a center disk or like a annuli filled up the periodic orbit. Therefore, we need to watch the saddle connection diagrams. And in this talk, these data of M means multiply connected exterior domain. M is the sum of the number of the elliptic center or circular boundaries. In this picture, M equals 1, 2. And one source sink is this. So one source sink is a very new structure. Yes. And uniformly flow is a flow with one source sink point. And why we can consider the uniformly flow is one sink source, because So if we consider like this flow, so if we consider the we add the point at infinity, so this so it's a 1 point compactification, so we can get some so this point is a point at infinity. Point at infinity. Then this is like this. So this is the same as so this flow can be considered. So if we add the point at infinity, and so enlarge these disks, and we can. So these two pictures is the same. Therefore, sourcing point is a sourcing point can be considered point at infinity. So therefore, so uniformly flow is a flow without one sink source. This is the reason. And so roughly, so one sink source point is a point into which is a combined sinks with a source. This so we collapse, it become so like this.
These are scotelets, or what do they call it?
Dipole.
It's just a standard dipole moment.
So
Yeah, dipole. So we can deal with so n-pole, but a little bit complicated. So this time I don't deal with. But you can consider n-pole. So as you can construct as same result, almost same result.
it's not really a generic configuration that then, is it? Because it's a combination of two regularities.
Yeah, exactly. So, but so one pole is a very generic in the non-degenerated one. So n pole can be separate n one pole, and so one pole is a very generic one. So, therefore, and almost if we cut the line, so if we first we consider n pole, we cut the domain, so we can consider the n domain with one pole. For example, sorry, yeah, yeah. Also, sorry. Anyway, after I And sorry. And so I also said so one source sink can be obtained also from two centers. So like this and like this. So if we consider two centers, so collapse this direction, so this also gets up. So one port. This is alternative construction. Yes, and formally, so one sink source is like this, one port. But if we change the times n and so n squared, it becomes n port. Yes. No. Yeah. And so we define so uniformly flow of precise is the following. So the vector field is a Hamiltonian vector field with one sink source point is a Hamiltonian vector field except the one source sink point. So because one source sink point is it not can be defined the function. Therefore, but so remove this point. So then we can get Hamiltonian vector fields. So and we denote by C1. Chi1 is a set of the Hamiltonian vector fields with the one sink source point on the domain. So we can obtain the analogy of the usual theory. So if we suppose with a Hamiltonian vector field with a one source sink point, and then B is structurally stable if and only if, so B is regular and all saddle connection and the boundary saddle connection are self-connected. Yes. Moreover, so these structurally stable, so Hamiltonian vector field with one sink source point is open dense. This is so also corollary of the last structurally stable theorem. Yes. Yeah. And so we also get a similar result. So we call the SS saddle connection or SS boundary saddle connection is the orbit between the one source sink point and the saddle point or boundary saddle point. Sorry.
Your source sink, in your source sink, does the flow go along the circle? Is the circle, or is the circle a rest point?
So yes, this is a rest point.
No. In your source sink.
Source sink, yes.
You have a circle.
Circle, yes.
And what is the two parts of the circle are flow lines?
Yes, this is flow lines. So
pull out the circle.
Just fill up the flow.
Yeah, but you've blown that up to a point. Yeah.
So fixed point is just one.
Yeah, but in your definition, you've blown that up to a circle, right?
Blown up a circle.
Or not? It's like this.
Just remove the point, I think.
Just remove the point.
Yes, just remove a point. Yes.
All right. So there's that circle's not there. There's just a single point.
Yeah. So remove this point, so we can define the function, and it's become a Hamiltonian function. So singularity point is so not defined, but remove, we can get the Hamiltonian function. Okay, and so actually this orbit is a SS. Sorry, no.
Actually, circles.
They're not circles. But they are circles.
This is a
Circles pinch at one point at the singularity point.
this is a SS saddle connection. So saddle and
Yes.
okay, I draw the more big picture.
When you say structurally stable, you mean your perturbation can't miss this point.
No, but we can so move the singularity, but we don't to remove because we deal with in the
Your space includes everything with this singularity, so your perturbation
yeah.
is the singularity.
But
So that's why they're structurally stable,
yeah,
modulo the fact that you're holding on to that singularity.
yeah, exactly. So, but we deal with the set of the Hamiltonian vector field with one sourcing point, and so therefore we can leave it so participate, but don't remove the one sourcing point. So this theory so can be shown.
No, I understand. I'm just
Yeah, but okay.
this question. That it's structurally unstable, but you grabbed hold of it and said it's staying, and therefore
Yeah.
consider structurally
Yeah,
stable.
exactly. So usual Hamiltonian vector field is a set of Hamiltonian vector fields. So sourcing is unstable, and but if we assume the existence of the one source and thing, so one sourcing point become a locally structurally stable. Therefore, we can show this.
I think there is a difference between generic and structurally stable.
Yes, there definitely is. Right. But if something is not generic,
What's the difference?
structurally stable is always an open condition. So
Yeah,
everything
exactly.
nearby looks the same.
Yeah.
Logically.
But exactly, so this set is not open in the Hamiltonian vector field. The very restricted, so small subset. But in this set, so structurally stable. This rho is a structurally stable in so chi 1. Anyway, so so this orbit is a SS saddle connection, and so this orbit is a SS boundary saddle connection. Okay, now we construct the so words. So first step is we consider these three prototypes. So we consider three words. So all words and one word are two words. So all words is so word representation for the usual Hamiltonian vector fields, and one word and two words for the Hamiltonian vector field with one sourcing point. And so last I say so SS saddle orbit or like this periodic orbit. So we don't need care about it. So therefore we don't like the periodic orbit, and we don't like like this orbit. So its orbit comes from the source and sink, source sink, and go back to the source sink. Therefore, this picture we draw like this. So one source sink point and the two boundary saddle. This is one source sink and one saddle, and there is no singularity. So we call Euler numbers. So cross disk has the Euler number 1, and the one source sink is 2. So saddle is -1, and the boundary saddle is -1/2. Therefore, this means two boundary saddle and one source sink equals the Euler number of the disk. This is one saddle and one source sink equals the Euler number of disk. There is no singularity equals the Euler number of the annulus. So this equation means like this.
When you say genus, you mean multiplicity. Genus 1 means it's torus.
Yeah. Genus, actually, we consider the symmetric. So if we take a double, so we consider symmetric vector field. This becomes a torus, and this becomes a sphere and sphere. This means that genus 0 means this disk, and so if we have one punctured, so punctured becomes a genus.
So genus 0, which of these diagrams?
Genus 0 is a 1, 2.
The four of them.
Yes.
Yes, and 2 are genus 1.
Genus 1, exactly. So we consider the double, and we get the torus, and we get the sphere. Yes, so genus means
Means the number of cylinders in the domain.
Yeah, exactly. So if we have the boundaries, so the genus is a K. Yes.
This is a non-standard use of genus.
Yeah.
Genus use torus.
Yeah, but in 2D,
Usually you call it multiplicity or connectedness.
So
one
yes,
connection
yes.
So number of boundary is that genus. And is that genus. Okay.
But the one in the middle at the bottom, you
Yes.
say it's -1
Minus
plus 2,
Plus 2.
but it must have another plus somewhere.
No, just one saddle
This is minus,
minus and
that is plus
this
2,
is plus 2 equal 1.
but there must be another plus, no?
No. So this has a Euler number 1, and so it has to become equal 1. So therefore, only these cases happen. So in
Yeah.
this.
That's okay.
So now we have the singularity only the center and the saddle or boundary saddle, just 3 types. So center is a +1. So we can't have, so in this case. And so we also consider about the equivalence of the schematic pictures. So these two pictures look like not same, but if we consider the sphere, this becomes the same. Now I just explain. So S is one source C, and there is one saddle. So actually, we have one boundary and outer boundary. So we can consider sphere and S and this is the same picture. So we consider so outer boundary. So this becomes this. So these are these, and we so reflect this. So this this become enlarged, and so this become outside. Then it's like this. So therefore, these two pictures are the same if we consider in the screen. Also, so we have so in this case we have three boundaries. We consider in sphere and reflect, and we get this picture. So this is also. So we can reverse and we can get this picture. And so this process is creating 1 and 2. And if we collapse the two to center, it becomes one source thing. So two center collapse to the one source thing. And now we so start to describe the words. All words is the representation for the Hamiltonian vector field. So all words have just three operations. So B0, B2, C. So B0 is so first we consider closed orbit, and we replace the figure 8 saddle. And so this is a B0. So B2 is replace the closed orbit to the boundary saddle connection. And C is so it looks like a B2, but a little bit different. So so C is two boundary saddle with so boundary saddle connection added to the circular boundary equipped with 2K boundary saddle. So we are so in this case we assume K more than equal 0. So this is K equals 0. So this case is K equals 2. K equals 1. So we'd like to so separate so B2 and C because so they so create so different structure. So C can be also work the so I1 and 1 word and 2 words. And I1 1 word and 2 words is so representation for so Hamiltonian vector field with one sourcing point. And so the 5 operations is so B0, B2, C, and so A0, A2. So this is these operations are the same. And A0, A2 is a little bit changed. So last one we considered closed orbit, but this time so we considered so the orbit so come from the source sink and go back to the source sink. So we call the SS orbit. So we replace SS orbit to the like this saddle, and so this is A0. So and if we replace the so boundary saddle, so this is called A2. And now we define the all words. So okay, and so suppose so Hamiltonian vector field is structurally stable in H. Then so we can be represented by the sequence of the operation of the starting from the O. This means so if we have some vector field. So if we operate the O0 and O1, O2 parallel, so we can get some vector field. It means first, we have the so O, so there is no singularity, and so we operate. So for example, so B0, and we get so like this. So this is B0, and so second, so we operate B2, and so we get we can get this and C, and we can get like this. So and if we operate so these vectors, and we can so every Hamiltonian vector field can be obtained. Oh, sorry. So can be obtained so like this sequence. Okay, and so similarly, so for Hamiltonian vector field with one sink source, we can obtain like this sequence. So this is so one A0. This is so two A2 like that, and so we can obtain every structurally stable flow can be obtained like this operation. So we have to consider the exchange of the operation, because so for example, so some operation is which have the same flow. So anyway, so the word representation is assigned for the structurally stable streamline pattern as a sequence of the operations. And there are many streamline patterns so represented by one word. So now I draw these words, but there is some possibility. So we can this picture is also this picture is also represented by these words, and so therefore we need to consider about the commutativity. But so it looks like not good situation. But so there is a good news. There is a inclusion relation. So this means, for example, this equal means A0, A2, and A2, A0. So we operate A0 first and A2 second, and the converse operation is creates same flow, but some kind of flow. So there is a inclusion relation. So for example, we watch this line. So B2, B0. So less than equal B0, B2 means B2, B0, B2, B0 means less than or equal B0, B2. And the last one is C, B0 is C, B0 is greater than equal B0, C. And so this symbol is incomparable. But another case is comparable. And this order is corresponds to the inclusion of the set of the structurally stable Hamilton vector fields. So
what does it mean, less or equal
on? So if we consider the O0 B2 B0 and O0 B0 B2, so they can represent, so for example, very few stream Hamilton vector fields, but they can represent many flow. For example, so this flow is B0, but this, but okay.
I'm afraid you haven't defined B0, for example. What is it?
B0 is
okay.
And C is like this.
So is the point just that any flow which can be represented by the word O, B2, B0 can also be represented by the word O, B0, B2?
Yes, O, B0, C can be represented this because so B0 can be applied this schematic picture. So this is an empty set, but this represents this picture. Therefore, this is bigger than. Yes, yeah. So if we change the operations, so this can be represents more words, more Hamiltonian vector fields. Sorry. Yes. Okay. So now, skips. I show some pictures. Okay, like this. For example, so yeah. Anyway, so like this picture, so it's also if we exchange the C and B2, so 2C B0 is don't represent any vector field and like that, and so this is a class subset of the set of vector fields. And yes, yeah, yes. So what means that so several stream pattern. Okay. Anyway, so last so.
And there's a typo on that, right? You mean B2C and CB2 are incomparable.
Yeah. So if we we can consider so many words, but some words so represent so very big many structure so Hamilton vector fields, but some small some words is very few. They have very few representation. Sorry. Okay. Oh, okay. Sorry. Anyway, so I go. But there's good news. So each structurally stable stream pattern has a maximal representations. It means every so structurally stable Hamiltonian vector field can be so represented by the maximal words. So, for example, like this, this is also the whole list of the so maximal words. So the Hamiltonian vector field on the so surface with genus 1 or 2. And so there's so more good news. So there is a canonical so representation. So it means so any maximal words can be represented so like this form. So there's a lot of so maximal words, but we can find the canonical form so like this form. So W is like this form. So therefore, so every Hamiltonian vector field can be represented by like this so word. So every Hamiltonian vector field so can be labeled so these words. And so one word is also has some so canonical form, and so it's also saying that I can say also the two words. And anyway, so I explain the words. So now I explain the whole pattern of genus 1 or 2 case. And so if we consider genus 1, so there are only 3 structurally stable pattern. So this is only 3. After we consider the 2 words, but one word so series is just only 3 pattern. And yes, and so genus 2 case is so just only this pattern, and so this is a same words, but they have really different shape. And yeah, so for example, this is have 2 representations, but this have also 3 representations. But if we exchange, so the class decrease. Yes, for example, so this A0, A0, B0 is sorry, like this. But if we exchange the I0, I0 is there's no flow, so represent the word. And like that. And two words is only 3 pattern. And so I have to notice that we don't distinguish that. So like this. To subtle, because this is a local structure, so this kind of problem is a combinatorial problem. So this time we separate from the combinatorial problem. So therefore we don't distinguish like this pattern or this pattern.
Well, you do distinguish if these two diagrams you've drawn on the blackboard.
Yeah.
Look over on the left.
Yeah.
You've drawn 2 cylinders in one of them and only one in the other.
Uh-huh.
Should be a second cylinder in the upper diagram also.
Yeah. So in this talk I don't distinguish, but if we distinguish, maybe we use some index. So for example, we use this B0 or B0 plus or B0 minus or B0 plus.
Well, they have different genus, these two pictures, as you.
No. Because eventually, first we consider the closed orbit, and so if we apply to the B0, so we can obtain like this. Sorry, I have to.
Right.
Sorry.
That is okay.
Sorry. Sorry.
That's correct.
Yeah, sorry, I missed to draw. Yeah. And anyways, so we can get this diagram. And so this is the conclusion. So we propose what representation for structurally stable Hamilton vector fields. And second, so we can construct the recursive function. It means that we can construct the algorithm. So that's from set of the all structure stable flow to the maximal words. So we can define the function recursively, and so therefore we can get all kind of structurally stable flow, and so this third one is the maximal all words can be represented part of the vertical string pattern. Consider the alpha long, and so last one. So we can determine all possibility string pattern in the combinatorial manner. So we can estimate the number of the structural stable flow pattern for genus. So actually we can estimate if we fix the genus, so how many structurally stable exist, we can by some calculus using a word of representation. And this is final slide. So future work. So we'd like to now. So we are writing the paper, and so bifurcation. And contraction deformation. So it's like disappears some island, so how to change the flow line and like that. And so we also we can consider the bifurcation graph. And so bifurcation graph is vertex is a structurally stable Hamilton vector field, and H is some bifurcation. So there's two kind of H. So one one edge is so come from the pinching. So another edge come from the heteroclinic so subtle connection, and so get that work. Oh, thank you very much.
Any other questions?
So your stream functions are harmonic functions, is this true?
Not really strict. So any function we can consider. So yeah.
So it's broader than potential flows.
Yeah. Yes. I wrote yes. But we can consider more general case. So if we consider the any function, we can get the Hamilton vector fields. So yeah, yes. So this time I explained like this, but so this works can be works in general case. So we can choose a function. So any kind of function we can.
Right, but it won't have a harmonic conjugate. It won't have a conjugate. It doesn't matter. But
No, they mustn't. They're not harmonic. The flows you're considering with the interesting topology, they are not potential flows.
Yeah.
The curl of the velocity is non-zero. They have vorticity.
Yeah.
They must have, because otherwise you couldn't have closed streamlines.
I thought
Unless there's, of course, a body in there.
yeah.
Closed streamlines around a cylinder, but not many of the diagrams that you've shown us. They're obviously rotational flows.
Yeah, exactly. Yeah. So complement of the
So
correction
to bring in the complex potential and the your phi velocity potential is totally irrelevant. What matters is that you have a stream function. Divergence of u is zero. That's all that matters.
Yeah.
And then you're considering the topology,
Yeah.
kinematics of such flows.
Yeah, exactly. So Hamilton vector fields, the orbit line is a level surface, and yes, and but therefore in general, so this framework can be worked.
It's even bigger. It's more restricted than divergence free, because in a multi-connected domain, there are divergent-free vector fields which don't have a global single-valued Hamilton.
But so if we
Like a point vortex, you pull it out, there's no need for the dual thing.
But if we consider the general compact oriented surface, we can cut along the periodic orbit or subtle connection. We can get the multi-connected domain. So if we pace the boundary, so we can get general cases.
But the point is Hamiltonian is more restrictive, divergence free.
Yeah, exactly.
It's not simply connected.
Yeah, exactly. So divergence-free case is there is no structurally stable flow. So on the compact surface with genus or positive genus, and so but the Hamiltonian is very restricted, so they exclude the irrational rotation. Therefore, so we can consider structurally stable. In general, so divergence-free case, so there's only exists on the subset of the surface. The structurally stable flow can exist only the subset of surface. And yes, Hamiltonian is very restricted. Yes, and divergence-free is more bigger than this. Yeah.
For example, if you think about just the source or sink flows,
Yes.
they are not Hamiltonian. They are gradient.
Yeah, exactly.
But if you put them together, so suddenly it becomes Hamiltonian.
No. So in this case,
With each fixed time.
so sink source point
So to have a stream,
is also the divergence free.
you have to watch out.
So therefore,
Connect
so
domains
today,
can have
so we deal with the divergence free vector fields, but in general case, so it might be some diverged.
simply
So
domain.
the so condition, so Hamiltonian except the 1-6 source. So this guarantee the
one-to-one
divergence free. But in general, it's not
Euler and all that. Correct.